In every single moment of our life, we are bombarded with an enormous amount of information from every inch of our environment. Have you ever wondered how does our brain handle all of it without exploding? Meet the symbolized and personalized model of the world that lives inside each of our heads. The perceptual world model. It is not the real world that you're seeing, it is your brain's version of it. If we want to understand how everyone is perceiving their environment and how they are navigating their life in their surroundings, we need to first understand the perception loop. As it is in my mind, one of the most important procedures to define and conceptualize the human cognition system. This loop cycle, which I will explain each part of it in details in this video, is showing us how we get every piece of information from the environment, then how we understand it and how we conceptualize it, and then how we add that information to our previous understanding of the world. And only then how the model of the world that we have created in our minds is navigating our upcoming observations and reactions to the things that are going on around us. Do you see that? This world model can influence our actions and cognition deeper than anything else. Now let's get to it. It's a loop and there is no objective start point to explain it, but I will start explaining it with sensation. Our sense organs scan the world and translate the world into neural pulses. The raw neural information goes all the way to the brain, and in the brain, responsible regions translate those raw information into meaningful and understandable features of the physical world. Your eye is telling your brain about the lines and colors and movements on a flat screen in front of you, the screen that you're watching me in. And your ears are observing sound waves of different frequencies, and they are telling your brain all about these waves. It is the brain that is understanding that there is a face on the surface and these words are being said in the voice coming out of that surface. The brain, after understanding the event or the object, starts to create a subjective model of it. This means that if you hit the subscribe button now, when my video comes up to your feed the next week, you will recognize me. I am Ali Amini, a psychometric master student who loves to talk about cognitive psychology. And you will expect to see some cognitive psychology related content by clicking on my video. Why? Because you have created an avatar of me in your mind. My appearance, my voice identity, the things you have seen me talk about, and every other feature that you can detect. After creating such an image, you will develop a list of expectations so that the next time my video plays around you, you will recognize me faster. You will recognize my speech easier because you are more familiar with the base vocabulary that I use, my style of creating sentences, and the subjects that I talk about. So it is in this way that the world model or the avatar will help you with your future sensation and perception. It will also ease your decision making. Why? Because you know me and you can easily decide if you are in the mood to watch one of my videos or not. So in this loop, we are constantly updating the picture we have from the world, and this picture is constantly navigating our future observation, perception, and actions. But is that all? Is this loop always working perfect? Is there any way to enhance our understanding of the world and have a better world model? Now let's get to details. I will tell you what is going on in each part of this loop and how errors in each step can take the whole loop down. The first place to look at is the sensation. We are moving and acting in the physical world. Our sense organs are responsible for transforming different qualities of the physical world into neural messages and send them to the brain. Each sensory module is in charge of a different quality. Our eyes detect electromagnetic waves that are coming to us, and by seeing them, by using them, we can see the outline of objects, different features of them, their location. Ears are sensitive to sound waves, or to be clear, frequent changes in air pressure. Sensing and smelling are basically scanning the chemical features of the air and the things we put in our mouth. And by skin senses, we detect danger or pain, temperature, and texture quality of the things that are close to us. By looking at ourselves in that way, we look like walking scanning machines. This multidisciplinary scanning method makes our scanning stage very accurate and strong, but yet we are prone to error. We might mistake a big rock for a bear in a dark jungle and run away from it screaming like a madman. So how can we enhance our sense organs? That is not what psychology is trying to do. An optometrist can help you with your poor eyesight better than me. An eye surgery, or like myself, using a pair of glasses, is a better answer to your visual problems than anything I can tell you. It is only after the sensation that the conversation about perception and what I can give you some information about starts. The perception system, as we are exploring it in this video, has 5 main functions: attention, localization, recognition, abstraction, and perceptual constancy. Attention, to start with, has 3 main jobs. Firstly, it decides how alert we are, or how strongly are we looking for information. On a trip to a city we have never been to, we are ready, absorbing every bit of information around us. Or when we are playing basketball, we are mentally and physically dedicated to the game. We might even miss everything else happening around us. In contrast, on a lovely, peaceful afternoon lying down in the backyard, nothing can bother us. We are just chilling, not caring about anything. There is nothing irregular or important or unexpected going on around us. One of the many differences between these 2 occasions is the level of alertness. This is the work of attention system. The next job of attention is called selective attention. This function of attention prioritizes and organizes the incoming information into a task-relevant list. This is done so strongly that we might completely miss other information available to us at the moment. Think of a 14-year-old boy playing a very interesting video game in his room. His mom goes in, puts a snack on his desk, and gets out. The boy might get shocked when he closes the game and suddenly sees the snack right in front of him. The third and last function of attention is deciding whether to continue or shift what we are attending to. A loud, explosive sound can always win your attention, no matter what else you're focusing on. Why? Because we are designed to rapidly attend to things that might threaten our survival. Survival is the most important task in our life. I hope that's not a shocking fact for you. There are other times that we shift our attention too. We stop reading a book to eat some food, and we turn off the TV to go to bed. This function is very important because if we don't use it properly, long dead scrollings on Instagram Reels or YouTube Shorts might steal many hours of our life on a daily basis. In fact, I think this function has never been this important in the human history. So if you have such problems and you are trying to find ways to enhance your performance in selective attention, tell me in the comments. I can make a deeper dive into it. Another problem that poor attention can cause is missing important information. We might be too focused on something and miss crucial, important information around us. This is called attentional blindness. Think of a driver who looks at their phone for a few seconds and doesn't notice that the car in front has stopped. The crash can be fatal, and please don't use your phone while driving. Moving on from attention, we need to navigate our ways around and grasp objects. That is why we need to understand the distance of objects from us, and also we need to predict their movement pattern to be able to act accurately as everything is moving. This whole thing is done by another function of perception called localization. Explaining how we perceive distance and motion needs a whole video dedicated to it because it gets quite complicated. So if you want that, tell me in the comments and I will make it very soon. Okay, the third function of our perceptual system is recognition. This is where memory comes in. We have in our memory what a triangle looks like, how our friend sounds like, and what a horse is. We compare the information around us to our perceptual history in a global to local process to understand what is what. What is a global to local process? When we are provided with a set of information, a picture for example, we first understand or perceive the primitive details. The colors, the shapes, the fact that there are 2 human figures in this picture, the picture is light or dark, and so on. Then we compare those details, those primitive details, with our memory, and we create theories, which we will test to make sure if they fit. That man looks like John from college. Check his body language, check if he has the face tattoo that I remember him to have, or not? Is that Karen's living room? Does it have the furniture that I remember? This theory and test cycle happens seamlessly in milliseconds, and this is where we are using our world model. The world model is basically the memory we have, and now we are checking the incoming information against that. For instance, imagine you're attending a party and there you see a very old friend of yours after many years. At first, you're not expecting to see her, so you just notice a very familiar face. You are trying to recognize her appearance, searching all your memory for a person who would appear like that. But her face has changed so much over the years that she seems unrecognizable. And then she speaks. You recognize her voice and everything clicks. You remember her name, the school you went together, and all your inside jokes from back then. It's exactly at this moment that your world model gets updated. Now you don't remember only her 12-year-old face, instead you have updated her avatar to the 27-year-old version that will actually work in future encounters, so that the next time that you see her, your updated world model will immediately recognize her, and that's it. The fourth function of your perceptual system is abstraction. This is where our brain takes the vast, messy details of the world and turns them into manageable concepts. We don't see 1,000 shades of brown and green in the forest, we see trees. We don't remember every tone of someone's voice, we just recognize their voice. Abstraction is the process of stripping away every unnecessary detail of the world and only keeping in the necessary and meaningful patterns. This function helps us think, plan, and communicate. Without abstraction, every moment would be a flood of raw sensory chaos. Imagine having to memorize every pixel of everything you have ever seen. Impossible, right? So our brain generalizes. This is why we can see a chair that we have never seen before, and instantly we can understand that this is a chair. Our perceptual system extracts the essential features, the flat surface, the four legs, and the size, and connects it to the concept of the chair that we already know. The concept of the chair we already know is part of the world model. You are looking at a chain of actions. The abstraction system compresses the data, and then the recognition system comes in, scans those compressed data, and makes the required connections to our world model so that we can understand and classify every new and unique object that we see in our life. But abstraction and this chain of activity is not just for objects. It applies for situation and events too. We just don't perceive events as isolated moments. We group them into patterns. A smile means friendliness and a frown means disapproval. And a raised voice means danger or emergency. Abstraction turns sensory details into meaningful features that are ready to be recognized. Finally, we have perceptual constancy. This is the reason why we can perceive things stably and consistently, even though the sensory input is changing dramatically. A red apple looks red in daylight, under the shadow of a tree, or under a fluorescent light. A friend walking toward us doesn't seem to grow bigger, even though his image on our retina, the tissue that is absorbing light in our eye, is expanding. We can still recognize a song if it is played in a different key, or we can recognize our friend's voice even on the phone. Our brain maintains constancy by correcting the raw sensory information using contextual cues and memory. In other words, the contextual cues is referring to the top-down process in which we first perceive a whole and the big picture, and then we perceive details considering what the big picture and the whole situation or the context is giving us. And the memory is helping us maintaining the perceptual constancy by the world model. We all know that nobody can grow 3 inches per second in height, so his picture on our retina must be expanding because he is getting closer to us. So perceptual constancy is keeping our experience of life coherent and predictable, even though the input is changing. Without perceptual constancy, the world would feel unstable. Objects would constantly change size, color, and shape, and we would live in a flickering, chaotic world where nothing holds its identity. Constancy is our brain's way of saying, don't worry, it's still the same thing. Together, these 5 functions are what makes perception possible. They transform the endless stream of sensory data into a stable, usable, and meaningful model of the reality, the world in our mind. And that's all about it. What we call reality is not the world itself. Instead, it's the model of it, or is the version of it that our brain builds. Our brain constantly scans the physical world, turns it into neural codes, analyzes it, and creates a symbolized model of the world in our minds. And also it uses that same model to predict, control, and update the way we see everything around us. The message is simple here. The world you experience is your brain's best guess of what is going on out there. And by understanding how this system works and how our perception, attention, and world model shapes our experience, we can make our observations more accurate, our decisions more practical, and our lives a little more clear. Knowing how our cognitive system works makes us a little bit more self-aware, more insightful, and ultimately a smarter human. Thanks for watching till the end, and if you like exploring the mechanics of our minds and brains, make sure to keep up for more content like this one.